In this video, we are going to look at the introduction to organic chemistry. Organic chemistry is defined as the branch or study of chemistry that involves the organic compounds. Now, organic compounds we are looking at organic compounds such as hydrocarbons. Now, we can see that we have introduced another term, hydrocarbons. So what is a hydrocarbon? So hydrocarbon is just an organic molecule that contains only hydrogen and carbon atoms, such as if we have CH4 here, we can see that there is only carbon and hydrogen. We may have C2, then H6, this is also hydrogen and carbon. So these are known as the hydrocarbons. Now, the second terminology that I would like us to look at is aromatic hydrocarbon. So what are these aromatic hydrocarbon? So these are just the hydrocarbon in which the carbon and hydrogen atoms are joined together in a closed ring structure. For example, let's say we have a structure like this one. So you can see that the way carbon are joined, they are joined in a ring like a structure. Then the other term that we can look at is aliphatic. So aliphatic hydrocarbon. Now these are hydrocarbons where the hydrocarbon in which the carbon and hydrogen atoms are joined together in a straight line. Like for example, we have carbon, carbon, carbon. So we can see that these carbons are joined in a straight line. So these are the two types of structures in terms of hydrocarbons that we have. Then from there, let's look at the term unsaturated. So under organic chemistry, unsaturated is organic compound that consists of two or more bonds. So we are looking at a double bond. So this is unsaturated. Also, this is unsaturated. So double bond is unsaturated. Triple bond is also unsaturated. Now for saturated, we are looking at the type of a bond where there is only one single bond between carbon to carbon bonds. Now, away from there, before we look at the first family of organic chemistry, which is alkanes, first let's look at the valence numbers on the periodic table. So from group 1 of the periodic table, the valence is 1. So elements that has the elements with the valence numbers such as 1 elements like you have lithium, sodium, including hydrogen. So these elements forms the single bonds. Then we have the second one, group 2, with a valence of 2. So these like calcium, beryllium, these forms 2 bonds. Then we have group 3. Group 3 has a valence of 3. These will form 3 bonds. Then for group 4, such as carbon likes to form 4 bonds. So we see 4 bonds like this. Then we have 5. 5 such as the nitrogen has a valence of 3. Nitrogen likes to form 3 bonds. Then we have 6. 6 such as oxygen has a valence of 2. Oxygen likes to form 2 bonds. Then we have group 7 has a valence of 1. Then group 7 likes to form 1 bond. So we can use the valence number to determine the number of bonds an element would like to form. So that is what I wanted us first to have in mind. So for group 1, they form 1 bond, group 2, 2 bonds, 3 bonds, and so on and so on. So that's a pattern. That's a pattern that you need to have in mind. Now, away from there, there is another point that I want us first we look at. We look at the prefix. Now, under organic chemistry, the prefix, we are just determining the number of carbons an element, I mean the number of carbon a compound has. So the first one, we have the meth, like from the word methane. Meth has 1 carbon. Then we have eth, 2 carbon, prop, 3 carbons, bute, 4 carbons, pent here will have 6 carbons, hex, sorry, for pent should be 5, pent 5, then hex will have 6, then hept, this is 7, then we have oct 8, non 9, then dec will have 10. So you need to have in mind of these prefixes as you are dealing with organic chemistry. Now, since we have an idea of what this represents, now let's look at the first family of organic chemistry. This is alkanes. So as we can see, we are looking at the family where the names of these are prefixes ends in a, n, e. Now, the question that we are going to ask ourselves here is, what are alkanes? So the definition for alkanes, number 1, they are saturated. They are saturated hydrocarbons. What did we say saturated means? Saturated means they contains only single bonds. So here we have no single bonds. Then the other characteristics that we can give to this definition for alkane, the alkane, their names ends in a, n, e. We have methane, ethane, propane, butane, pentane, stuffs like that. Then from there, these alkanes, they are almost stable. They are stable, and the reason why they are stable is because they have single bonds. So it's hard for these alkanes to undergo certain reactions unless maybe some conditions have been met. Then apart from having the single bonds, their name ends in ne, then stability. The other thing that we can see, we can look at here is they obey to the general formula Cn 2n plus C2. So that is the formula to which alkanes obeys. Okay. Now, since we have some introductions for this alkane family, let's look at the first examples. So first example, we'll look at how to determine the molecular formula and the structure formula for each molecule that we are going to write below. So the first one, the question is write the molecular and the structure formula for the following molecules. So the first molecule, we are going to look at methane. Then the second one we'll look at ethane or ethane. Then the third one we'll look at propane. So you get the picture. Now let's look at the first compound here. The first compound is methane. So we can now break this methane into two groups. So the first part here, we can see we have meth, and meth we said is one carbon. Okay, then the other part here we can see it's ane. So the ane, this is the suffix. This one indicates that the compound that we are dealing with is coming from the family of alkanes. So how can we write the molecular formula for this one? So first we need to write the equation. So the general formula for alkanes, so it is Cn 2n plus C2. Then the first thing that we are going to do is we need to look at meth. Meth has one carbon, so where there is any from our formula, we need to substitute with 1. So let's do that. Okay, so we can now multiply C times 1. Here we are going to have just 1C, then 2 times 1 here, it's 2 plus C2. Then we can now add 2 plus 2 is 4. So this is the molecular formula for methane. So for those that may just have mastered this formula, so this is how this formula came into existence. Now, since we've written the molecular formula, we can now move on to our structure formula. So whenever you are trying to write the structure formula, first you need to write the carbon atom. So here we can see that we only have one carbon, so you write one carbon. Then remember we said carbon is in group 4, and group 4 elements likes to form 4 bonds. So we are going to put 4 bonds. Okay, so then on each bond we are going to attach hydrogen. So this is our molecular structure for methane, and we can see that it has obeyed. Hydrogen has each hydrogen has one bond. Then the total number of bonds for carbon is 4. Now before we move on to ethane, let's try to see what we can add on this one. Okay, so the first one here, what we are going to do is what I want you to know is if we have this carbon, then each bond consists of 2 electrons. So what this means is there is one electron from the carbon and 1 electron from the hydrogen. Also here 1 electron from carbon, hydrogen, then just like that. So this is the picture of what is happening here. So that is what you need to have in mind. So each single bond contains 2 electrons. So we can see each hydrogen is satisfied because we say the atom for hydrogen is occupied with only 2 electrons. Okay, now away from there, let's move on to question Roman number 2. Now for Roman number 2, we'll begin with the same molecular formula for ethane. Then later on we'll look at the structure. So let's first write the general formula. Okay, so now let's break our name into 2 parts. So the first part here we have eth. So eth, from this we can look at, we are looking at 2 carbons. Then ane, this one tells us that it's an alkane family. So let's begin. So let's substitute N with 2. Okay, so if we multiply C times 2, we have the subscript of 2 here. Then 2 times this 2, we get 4 plus 2. Then our final molecular formula is 6. So this is the molecular formula for ethane. Then from there we can move on to the condensed structure. Now look at the number of carbons this time. So we have 2 carbons. So we draw the first carbon and the second carbon. Now remember, we are dealing with ANA. This indicates that we are going to have one single bond between the 2 carbon atoms. Then from there we can see that each carbon has one bond. So we only have 3 bonds remaining. So we put one here, the other one here also. So we'll do the same to the other carbon. So this indicates that we have 1, 2, 3, 4, 5, 6. So this is our 6 hydrogen. So I'm sure by now you've gotten the picture under alkanes, so you can pause the video and try the molecular formula and structure for propane. Now let's write now the propane. So begin with the same. We need to break this into, so we have prop and we have ANE. So prop indicates that the number of carbons are 3. Then ANE indicates that we are going to have the single bonds between carbon-carbon atoms. So let's write the formula. CN 2n plus 2. So C, where N, this time we have 3. So 3 plus 2. So C times 3 is C3. 2 times 3 is 6 plus 2. Then our final answer is C3H8. Now we need to draw the 3 carbon atoms. So the first one, third, and second and the third. So we need to put the single bonds here since it's an alkane. Then here we are going to have 3. So we put 2, 3 here. So we can look at the number of hydrogens. So we'll have 1, 2, 3, 4, 6, 7, 8. So we can see that we still have our 80 number of hydrogens. Okay, so now we move on to how do we name some of the compounds from the alkane family. So let's look at the first example. And so let's say we have this. So the question is, provided you are given a condensed structure and the question is asking you to name this. So how can you name this structure that you are seeing on the screen? Okay, so when naming a structure, first we need to indicate the prefix. Remember, the prefix we said was the number of what? Carbon. So how many carbons do we have? So 1, 2, 3, 4. So from our list we said this is, but then the second one we need to consider the suffix. So the suffix are the bonds between the carbon atoms. So we can see that we only have the single bonds here, no double bond or triple bonds here. So the suffix is ANE. Then from there you can now just connect the names. So we are going to have butane. So this is how to name a molecule from organic chemistry. Now let's look at one more. So let's say we have this one. Okay, so here we'll have another condensed structure. So our first step, as we said, we need to determine the prefix. Then from there we need to look at the suffix. The word prefix means the beginning part of a word, then suffix the ending. So the prefix we can count to have 1, 2, 3, 4, 5. So if we have 5 carbons, what is our prefix? We said it's pent. Then from the suffix, we need to look at the type of bonds between carbons. So here it's a single, also here single. So we are dealing with a compound with single bonds, between all carbon atoms. So here we are going to have A N E. So our name will be pentane. So this is how you can name a compound from alkanes. Okay, now let's move on to isomers of alkanes. So what is an isomer? So an isomer is just an organic compound. Is just an organic compound with the same molecular formula but different structure formula. So what is this means in terms of the structure? So let's have 2 structures. Then from the 2 structures, we'll determine if these 2 structures qualifies to form the isomers. So our first structure is this structure. Then also under this part, we need to look at how do we name these isomers. So we need to name these 2 isomers. Okay, so then this is our first structure. For you to identify isomers, you need to have 2 or more structure. Then let's look at structure 2. Under structure 2, we have this. So we need to look at first the chemical formula for each compound. So we'll begin with the first one, our compound A. We'll begin with our compound D. So let's call this one our A. Then here we have our B. So here, first we are not looking at the naming. First, let's look at the molecular formula. We already see that we have seen that the 2 structures differs, but we need to check for if the molecular formula are the same. So let's count the number of carbons here. So we'll have 1, 2, 3, 4. So we have 4 carbons. Then let's look at the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 atoms of hydrogen. So this is our molecular formula. So now let's move on to structure B. Here we have 1, 2, 3, 4. So we can also see that we are dealing with a molecule with 4 atoms of carbon. Then the second one, let's count the hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 atoms of hydrogen. So the first part, these 2 formula are the same. So these 2 are isomers since they have the same molecular formula. Okay, so we are done. So that is the first thing that you need to look at. You don't just look at the structure. You may have different structures, but if the molecular formulas are different, therefore you are dealing with whatever that you are dealing with are not the isomers. Okay, now let's look at the naming part of this. Now the first one, you can see that the first one is simple. The first one, we just name it the way we did with the other example. So we look at the prefix. So the prefix here, we need to count the number of carbons. So it's 4. So here we need to have but. Then suffix. The suffix here, we are going to deal with the suffix, it's a single bond. We can see we're dealing with single bonds, so it is ANE. So the actual name here is butane. Now for structure B, where you have a different structure in terms of the arrangement of carbons, you need to be extra careful. So from this party, we can see that we have this part here that is branched. So we have this branched party, it has one carbon. Then we also have the other part, this one, with 3 carbons. So what do you do whenever you are trying to name a structure like this one? So the first one, you need to indicate the main branch. So this is our main branch because it contains more carbons compared to this one. So we have the main branch here, or the parent branch. Then this is our branched. So we have the branched here. So branched, how do you know that this is the branch? You look at the one with the lower number of carbons. So the branched has 1 carbon, the main branch has 3 carbons. So whenever you are trying to name the branch like this one, you begin with the branched one. So how many carbons are there in the branched one? We can see it's 1. What is the prefix for 1? We have meth. Now the rule here is a branched one is a single carbon atom or chain of single bond atoms that are joined up with a main chain. So here the rule, after you identify the prefix for the branched one, you need to add YL. So this becomes methyl. If it were ethyl, eth would have ethyl propyl. So that's a pattern. So whatever prefix you get from the branch one, you need to add YL. Now from there, we need also to look at one thing in consideration. So here we need to look at the position of the carbon where the branched is branching. So if we move in this arrow, we can see that the branching is on carbon number 2, since we said 1, 2, 3. Now let's look at if we move from here, we move in this direction. So this is carbon 1, then we have carbon 2, we have carbon 3. So either direction, we can see that we are getting the same number. So in this case, we can see that if we move from left to right, it's position 2, right to left, it's position 2. So we just put 2. So you put 2 in front and the hyphen between the number and the alkyl group. So that's a picture. Now what if you have okay, we'll just look at that later on. So we are done naming the branched one. Now from there we can go to the main branch. So how many atoms of carbons are there in main branch? So it's 3. What is the prefix for 3? We have prop. Then what type of bonds do we have? We can see that we have single bonds. So we add A and E. So this is the name of this particular structure. Okay, let's look at another example, but this time we'll just look at how we can name another compound where we have a branch. So let's say we have 1, 2, 3, 4. Okay, so you can feel free and try to name this structure. Try to name this structure. Okay, so we need to identify the main chain, and we need to also look at the branched one. Okay, so from the diagram, this is our main chain, because we can see we have 4 carbons here. So we'll have the main chain here. Then for this one, this is our branched, since we only have 1 carbon. Okay, so now after we are done this, what is our first step? So our first step, we said we need to look at the prefix for the branch. How many carbons are there in the branch? So we can see it's 1. So it's 1. So this is meth. Then the rule is you add YL. Then after we are done, let's look at the locant. Let's look at the locant for this branch. The locant is, we want to look at the number of the carbon atom where the branch is. So this is, let's consider this is our carbon 1, 2, 3, 4. So if we move from left to right, our branch is branched on carbon 3. Now let's try to move from right to left. So this is our carbon 1, carbon 2, carbon 3, then we have our carbon 4. So in this example, we have 2 different numbers. So the one is giving us 3, the other one is giving us 2. So which number are you supposed to choose? So in a case where you are getting different numbers, you always get the lower number. So we'll get 2 instead of 3. So that's the pattern. So it is 2-methyl. Then we go back to naming the main chain. Then from the main chain here, we can count the number of carbon that we have. So we have 4 carbons. What is the prefix for 4 carbons? It is bute. Then the type of bonds that we have, we can see that we only have a single bond. So we have A and E. So this is our name for this particular compound. Now, for the last part for this video, we'll look at some of the chemical properties of alkanes. Now, alkanes are generally unreactive because the bonds between the carbon atoms are stable and the molecules lack a specific site of chemical attack. So what this means is we're saying we only have the single bonds. So it's like they are stable. They are stable. Now these compounds are stable. Now even if they are stable, we have some of the chemical properties of reaction they can undergo. Number 1, the alkanes undergoes the first one, combustion. Now what is combustion? So combustion, it is just the reaction of any alkane compound with oxygen. Now what are products? So the chemical reaction can be, you get an alkane plus C, you react it with oxygen. Then you get water plus carbon dioxide plus energy, or we just say heat. So if heat is produced, therefore this kind of reactions are known as exothermic, where heat is given to the environment. Now if you are given a question like you need to write a combustion reaction, you ignore the heat part. So let's say we have the example of methane here. So if methane is reacting with the oxygen, remember oxygen should be written as a diatomic molecule. So here we are going to have water. We know water, then plus carbon dioxide. Then what we need to see is this reaction balance. So this reaction is not balanced because here we have 4 atoms of hydrogen. Then on the product side we only have 2 atoms of hydrogen. So how do we balance? So we need to look at the number that we can multiply by 2 to give us 4. So we need 2 in front of water. So now here we can see that we have 4 hydrogens, and also 2 oxygen plus these 2, 4. So we need a 2 in front. So this is our balanced chemical equation. So even the other alkane molecules like ethyl propane undergoes the combustion to produce the same product. Then the other chemical properties in which alkanes can undergo is cracking. Now, what is cracking? So cracking is just the process of breaking down more complex molecules into simpler molecules. For example, let's say we have this more complex with 4 carbons. Okay, so we'll say we are going to let this molecule undergoes the process of cracking. So what can we get? So we are saying if this undergoes a process of cracking, we are going to break this complex molecule into simpler ones. So we may have products such as methane plus propane, where we have a double bond here. Now what you need to have in mind is if a certain molecule undergoes cracking, the products that are produced, the number of hydrogen atoms and carbon atoms should be equal to the number of hydrogen and carbon atoms in the first compound. So we can see that we have 1, 2, 3, 4. We still have maintained. Then hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We still have 10. Then the other products that we can get from butane, we can also get products like ethene. We have double bonds here, 2 ethene. So this one plus another ethene. Then we can see that we have 8 hydrogen plus hydrogen. So this is what we call cracking, where you have 1 but you make 2, or sometimes you make 3 products that are simpler than the parent one. Okay, now let's move on to another chemical property. The alkanes can also undergo what we call substitution. Now, what is this substitution reaction? So, substitution reaction, it's a reaction with an alkane with one of the halogens or the elements from group 7. Now, for this reaction to occur, it has to be in the presence of light or at high temperature. So we need a condition like high temperature. So for example, let's say we have methane react with let's say we have chlorine. So what happens under substitution reaction? So what you need to do is the carbon does not change. The carbon or number of carbons does not change. What changes are atoms of hydrogen. So since it's substitution reaction, 1 atom of hydrogen will be subtracted by or substituted by 1 atom of chlorine. So what we are saying is we are going to have 3 atoms here. You subtract 1, 3 atoms of hydrogen, then plus 1 atom of chlorine, plus then the hydrogen that we subtracted is here, then the other remaining chlorine will have this one. This is what we call monochloroethane. Mono means one, so we only have one chlorine, so monochloroethane. Now in terms of the structure equation can also be given like this. Then we have Cl. Remember, Cl likes to form single bonds because they have the valence of 1. Then we have this carbon, 1, 2, 3. So these 3 hydrogens will be here. Then here we are going to have this chlorine atom plus HCl. So that's a picture. So here, since we only have 1, that's why we are calling this as monochloroethane. So that's the name. If we had 2, we would have called it dichloro, 3 trichloro, 4 pentichloro. Then the last chemical equation for alkanes, we can look at steam reforming. Now for steam reforming is also one of the ways in which hydrogen can be formed. So whenever they are trying to prepare hydrogen, they can use steam reforming. Now steam reforming, we are looking at, we have an organic compound such as methane plus, now this time we react it with the steam, which is water in gaseous state. Then we are saying we are heating this, so we supply heat. So the product we need to have carbon monoxide instead of carbon dioxide plus hydrogen. So plus hydrogen. So these are our products. So we can put 3 here so that we have 3 times 2, 6. 2 plus 2, 6 also. So this is what we call a steam reforming, where we have products such as carbon monoxide and hydrogen here. So that's it for this video. If you find this lesson interesting, please give it a thumbs up and don't forget to share and subscribe. Thanks for watching.